Okay, now, still remember this lovely equation? Any one of you have a problem with it? We will use it intensively in this chapter. So if you have any problem, let me know. Okay, we will use it a lot. Okay, let me show you the history. The history is, it is not the history of the Bernoulli equation, the history of this Bernoulli equation in fluid mechanics. In your chapter 3, yes, in your chapter 3, right, the fluid dynamics, you are introduced to Bernoulli equation without HS and HL. Is that true?
Yes.
Right? You measure P1, you measure V, you use it for a flow measurement, you measure the velocity from the pressure difference. That true?
Yes.
In chapter 5, conservation of energy, right? The second last term is introduced to you, right? HS and HL. Do you remember it?
Yes.
And this one is not called Bernoulli equation anymore. You either call it mechanical energy equation or extended Bernoulli equation. Okay, that one is in your chapter 5, conservation of energy. In your chapter 8, okay, in chapter 5, usually HS and HL is given to you. The equation is given to you just like that, right? You have these two different things, right? Two different reservoirs. You drive the turbine and the losses there is given, and you need to calculate the HS. That's the question. The HL is given to you just like that. In chapter 8, viscous flow, if you still remember, or you get it, or you don't get it. Viscous flow, the lecture will tell you how to calculate the major losses and minor losses. Still remember?
Yes.
Good. Then I don't have problem with that. So you can calculate the major losses from the Moody chart that make you moody. It depends on your lecture mood also. Moody chart, you can calculate the F, then you will calculate L over D and so on. And KL is given depending upon whether you have 90-degree elbow, 45-degree elbow, 20-degree elbow, whether you have a contraction, expansion, entrance, and exit. All those things has their own KL. Okay, so then you can calculate that. So in this course, in this chapter, unfortunately, the thing that you need to find is the F. Sorry, not the F, the phi. In chapter 5, in chapter 8, the phi is given to you. Sometimes the Q is given to you, right? Okay, this is the Q, you calculate what is the losses. That one is lovely question. You can do calculation easily. Okay. Now in this chapter, because the outcome is to design, basically you need to find what is the design Q. You are given a problem, you are given a pump characteristic, then you need to find the flow rate in that particular system. So that's the question. So that's how we drive you from there into here. Okay. So here, what you will find is this. Okay. But don't worry, I'm not evil enough. Phi will be given for you. F will be given to you. If F is not given, you know it will be trial and errors. Right? Because F is a function of Reynolds number, and Reynolds number is function of velocity. But you do not know the velocity because velocity is function of F, and F is function of Reynolds number, and Reynolds number is function of velocity. Got it? If your lecture is very bad, you see this. So you have your F, is function of phi. Sorry, function of and Reynolds number is function of velocity. But you see here, if you want to calculate the velocity, you need to get the okay? This is similar to you don't like the class because you hate the lecture. You hate the lecture, you do not come to the class. You do not come to the class, you do not know anything about it. You hate the lecture even more. Then you do not want to come to the class. Now, because you do not come to the class, you do not know what happened. Then you even hate. Yes. Okay. Just like that. So, I don't want to do that, so usually this one will be given to you in this course. Okay, so that we just remove this cycle first. In real life, will it happen? No. You need to find. Okay, depending upon your velocity, right? You need to find the velocity, then you can calculate the F, the real F. From the F, you calculate the. So it will be kind of iteration. Okay. Last time I invited IR Zainuddin from PPM, Petronas Penagisan Melaka, to give a lecture especially for this. So he designed the pumping system for Petronas Penagisan Melaka, and he is the one who involved in this the development of Rapid. You know Rapid program? It will be the biggest refinery in the Southeast Asia, 3 times the capacity of Melaka refinery, a joint venture between Aramco and Petronas. So if you want to get high paid, right? High paid in Malaysia, you can do that. You need to be good in mechanics. Okay, so we will use this one. Okay, so let's take a look at this one. This is a very unlikely arrangement where you have pump with different inlet and outlet. Maybe the owner is a bit eccentric, a bit unique, that you want to have a pump with a different area. Okay, in this case, if you have this kind of pump, of course your P1 will be different with P2. Okay, which means you will have this. Your pressure one, of course, different with P2, right? And then the elevation, if you have like this, the elevation will be different. So the power the enthalpy or the energy provided by the pump is given here. Okay. This is the most unlikely pump, right? Because usually the elevation difference is very marginal, right? Your pump is big. Inlet is there, the outlet is there, so the difference in Z is very minimum. You can neglect it. Okay? And then the inlet and outlet usually has the same area. If you have the same area, mean the velocity is the same. So usually when you are calculating for the pump, you're just calculating the delta P, pressure jump or pressure difference, right? Provided by the pump. Okay, so if you want, sorry, this one is not enthalpy. This one is the head provided by the pump, the delta H. You see the H there? This H. So if you puncture the pump, if you puncture the hole here, and then put a tube there filled with water, okay, you can measure the head at the inlet, and you measure the head at the outlet. So the difference between those heads is your pump head. Okay, your pump head is that delta H. Okay, and if you get your pump head, you can calculate your water power. This is not pump power. This is the water power received by the. This is the power received by the water from the pump, not the power provided by the pump. Look. It's like this. I give Sharon 1,000, okay, to disperse to you, to be given to you later on. But because Sharon, Sorry, because Sharon is not 100% efficient, so he will take 100. She will take 100 and disperse 900 to you. So the 900 is this. Right? The power received by the water from the pump is not 100%, right? Because there is some losses. Okay? So this one is the water horsepower. Okay, the water horsepower is m dot times G times delta H. This delta H is the pump head. You need to calculate it from the Bernoulli equation, inlet and outlet. Okay, this delta H is nothing but this. Okay, before I continue, I want to remind you that this delta H sometimes will be called HS, sometimes will be called HP. Shaft head or pump head or pump head. Okay, don't get nervous. Okay, later on you ask me in the question, why there is no delta H there? That's it. Delta H, HS, or HP. Okay?